getting going. And as we are already seeing in the slide, this is a paper by Mr. Pradip Roy for processes for assessment, certification, safety approval, interoperability of ERTMS and implementation of the ERTMS systems to European standards. So this is a short slide which comes up for our forum which we have, and this is our website at osd.net/. So this is a flyer which we had already calculated. I'll give a quick introduction of Mr. Roy. He is a principal project engineer who is presently situated in UK and working for Siemens, UK, and he has been a past. He has been in the past. We got all. If you can help, if you see somebody waiting, if you can click the other speak. Mr. Roy had post-graduated from the Calcutta from the University of Calcutta, and Arun has just joined, and he has been an engineering graduate from the Institution of Engineers, India. He had later taken a management degree from Manchester University in UK. His career started with a medical instrumentation, where he worked for about 4 years, and then he joined the Indian Railways. While he's an engineer, he has also published papers on physics in international journals. He had worked on the Indian Railways for some time, and then he joined the UK Railway in 2001. He's an FIRSC, FIAT, and FFPM chartered engineer and physicist, as well as a Six Sigma certified and a qualified lead auditor. Further, he conducts interviews for engineering, CEng, and CFIX applicants. He is a workplace assessor, competence assessor, as well as a technical mentor for IRAC licenses. So he has quite a long list of his professional achievements. He, in the present or the past, had worked on railway signaling on various signaling companies like Alstom. He had worked on the Network Rail in UK, the Docklands Light Railways, which incidentally I believe was the first railway to start sometimes in 1834 or somewhere for the which railway was the first to have a passenger flight, and then he worked with Praxis, and now he is working in Siemens. He's a dynamic and a visionary leader with a commendable background in railway signaling systems engineering for 32 years, possessing a wealth of technical skill set, and delivered multiple signaling and safety critical systems projects as project engineer, project manager, engineering manager, as a compliance manager, as well as a V&V manager. He has worked for NATO as a principal safety consultant. His achievements spread over project delivery and of novel systems. He had worked on Ansaldo CBI, the Siemens AZ350U axle counter, ETCS level 2 signaling, and he is the first to execute the interoperable processes in accordance with the ERACCS EIC regulations in the UK. With this, I will hand over the floor to Pradip to start his presentation. Pradip, you can take the control and yes, go ahead, please.
Okay, thank you, Mr. Manager. Thank you so very much, and thanks to all who have joined today. Before I'll just share my presentation first. Where did it go? I hope you can see my presentation.
Yes.
Yeah. Okay. Excuse me. Actually, one of my most important aspect of this is a compliance of the interoperability and safety, which will come in more details as I go along. And I have outlined the features that I have encountered during the process of getting an NOBO DBO approval. If somebody, I think there are some people who are not aware about NOBO DBO. That is, the NOBO is actually a notified body, which I'll come to details later. DBO is the designated body, which is a part. These are the two things that we need to go for approval if we have to go for an interoperability product like ETCS anywhere in the world. People do follow the ERA process. People do not do some bypasses of the ERA process, but at the end of the day, they do follow somewhere or the other the ERA process to go ahead with it. So my presentation actually covers two important aspects. That is what actually we are doing in conventional signaling and what aspects that we are trying to achieve when we are doing the second part, that is the novel signaling, especially the ETCS for the future. And this is something which I have delivered in many places, of course, in a different way. I've also delivered in IRSC. I've delivered in Birmingham University as part of the approval processes of MSc signaling and codes, and of course internal in Siemens too. So, and thank Mr. Banerjee for giving me an opportunity to deliver it here. So as I go along, so the first thing is we need to understand what is a definition of compliance. So when you are trying to do compliance, we're actually complying a lot of factors like guidelines, that is network rail company standards and others. I'll come in details all those. The specifications outlined for the project, then we have got the contract technical work scope for what the client is looking for, and also certain industry regulations and certain government regulations along with it that encompasses the whole scenario. So as a company, it is a foremost duty to ensure that the company follows the regulatory standards. It's mandatory to follow the regulatory standards applicable to the railway business. So the important of this process is that we need to ensure that we do not violate this process in any or other. So on the other hand, since being a lead auditor, I also take into account of the engineering process and also ensure that the process do carry out for projects, because I cannot do on my project, but I do engineering audits on other projects as a certified lead qualified auditor for ISO 9001 2015. So let's have I've given a certain idea about a bird's eye view of what is actually a project compliance looked at. So when you look at the project compliance, we actually have people in projects, we have control systems, we have application designs, we have system engineering, we have configure and the project files, the safety, the testing, the interoperability, the EMC, the product, and of course, the new aspect has come as security. Excuse me. So my aim of this presentation actually relates to two factors. One is the safety and the second is the interoperability. So these are things that actually came out very recently, and we have to work out on those two factors in great depths, which we are actually adhering to and mandatory to cover all those areas that we are working out for any projects in UK Railways. So what actually you're doing when you're having a project delivery process? So we are having a project commencement, we are having a project handover. So there are a lot of steps that takes place. So in UK, we follow the GRIP process, the GRIP 1, which is coming as the feasibility study, where GRIP 2, GRIP 1 is concept development, GRIP 2 is feasibility study, GRIP 3 is option selection, GRIP 4 is final option, GRIP 5 is the installation and testing, GRIP 6 is commissioning, GRIP 7 is handover. So we follow all this process. So this has been changed over to coming as project speed, which is completely new scenario, but actually they have compiled some of the GRIP processes into there. So I'm not going into those details. So I'll just cover some of the important factors. So we have the option selections and the value engineering, which actually covers up certain standard compliances and constants. So the important part that we take over it's a hazards that starts from the very beginning. So we need to identify the hazards when you're trying to work out on a project. Then when you go for the fixed option, we actually go for the standards used, and if any variation has come up and any new option has popped up. So what happens when you are doing an existing mitigation? That means when you are finding into a final option, that means there might be sort of other issues coming up, like installation of certain areas, location of certain things, location of signals, and all those stuff. Second is the construction at site, which comes out the site hazards and risk, personal safety, which have access to people, which have an access to the location, the siting of locations, the overhead wire, whether it's coming out on top of any locations or anything as such. The fourth is the test and commissioning, which actually covers the standard compliances, risk mitigated, design approved. So we have got an approved design and got an approved product before it's finally commissioned into it. So the whole endeavor comes into the safety. So the one that I mentioned earlier about, we are looking at the safety. So you're looking at the safety aspects on all these four aspects before the comments, after the commencement of the project, before it is handover. So safety is carried out throughout the project. So what are the safety approval process? So safety approval process comes as the safety management system, safety assurance system, and the project authorization, that is system review panel, which is a part that when here actually the one important thing I like to mention here, that I'm speaking with a hat on of UK Railways. It might vary to different by like, and the project authority might be CRS in India and some other place, and might be some other different in Australia or in Malaysia, something. So I can, since I haven't worked out, so I don't want to make any comment on those. So the three things that we need to cover in those areas. So what do we do for conventional signaling? We have the safety engine documents, we have the safety case, we have the technical file, we have the independent safety approvals, we get the project documentations, which actually covers up all the safety approvals. In the UK, we have got a CIP who actually authorizes to go for commissioning, taking into account all the ensure that all the hazards identified, mitigated, all the designs completed, approved and signed off, and give the safety assurance. But when you're coming into the concept of novel signaling, we have a completely different scenario. We do still have the safety engineering aspects, but at the same time, we have the applied body, which is actually what I call the NOVO. It is now called the applied body. We have called the designated bodies. We have called the associated bodies. So the associated bodies is equivalent to what you have done for the conventional signaling, but in a much wider angle, because it also uses the application not only of the systems, or not only of the products, not only systems, and also for the system of systems that you are trying to use for the novel signaling. So that actually confers my safety approval for the novel products, and the process still goes in the same way and comes back to commissioning. I will go in details later on how this part of the thing actually carries out in depth. So this gives a more clear picture about what actually we are doing at part of UK Railway. So what do we have conventional signaling? We have got the railway group standards, we have got the railway industry standards, we have got the network rail company standards, we have got the CELELEC standards. So the basic thing of that we have to abide by all the four conditions for the four standards in multiple ways. Just to say one thing, the railway group standards, the railway industry standards, and NRCS do changes every 3 months. There are certain things that come up, there are certain things that goes away. As a part of the project initiative, we need to ensure that these are complied in all respects. But one important thing is when you have a project commissioning and a first stage of the commissioning, we freeze the standard onto that particular issue. And if there's any variation later on in the projects, we'll be mandated and with an impact analysis and the cost and the time that we take into over as part of our project plan. So what we have compliance signaling, we have actually the common safety methods. Common safety methods has been introduced for the after we have actually gone away with the yellow book. Yellow book actually covers the 7-step process. The common safety methods actually covers the 7-step process, but in a more defined way. One of the important factor in a common safety method is we have to define the project is significant or insignificant. That means it has a significant risk or insignificant risk. Any risk that is covered, all new projects are non-significant. a non-significant has to go for hazard analysis and all stuff. So I'll just give an outline that how does this work. So it covers the safety level, the safety targets, and the safety requirements that need to be fulfilled. So how does it work? It identifies the hazard. So the common safety methods actually starts what I mentioned earlier is the group 2 stage of that is the concept of the project. That means what are the safety that is required to cover in the common in the project. So in that case, actually we have got a 7-stage scenario. So 7-stage scenario actually comes from the preliminary system definition. System definition actually covers all the details of the project about how it is going to cover, how it is taking place, what are the things that is involved, what are the systems that is involved, what are the system of system that is involved. Then we have that is covered by another definition of the standard. Then you have got the changes. What are the significant changes that has been coming into the project? Isn't for a new project, it's a big significant change. So you have to identify all the changes. Then you have got the risk assessment as it is covered as standards. You have to identify all the risks associated at the beginning of the project, and it is what is called a live document and carries out throughout the end till it goes for the final safety approval before commissioning of the project. Then we have got the risk analysis. So one of the important factor that we have to analyze the risk, you have to mitigate the risk, and you have to go for ALAP. ALAP is something which actually covered from Yellow Book, and now we're actually covering from the analysis, and we need to ensure that we do not have we have sufficient risk, because at the end of the day, we have a Salesforce system that usually covers all those areas. Then how do we manage the hazards? So that's also a part of the analysis. So is it a what type of risk it is that define the causal factors, that the impact and the outcome of the impact. So that is another completely different scenario. I'm not going into details about those areas. That's risk analysis comes in as part of the safety aspect. So we need to identify the hazards. So we have the hazard log, we have the hazard identification, and we ensure that all the hazards are captured before it goes into the safety case. So this actually comes into as part of hazard management procedures. So we need to understand how do you comply the safety requirements in those areas. So that is a safety part that goes into the compliance of. So you have to provide the safety case. And first of all, you need to provide the safety and the closeout of all the hazard. Then you have find the safety requirements, compliances, and you get the safety case. And finally, we actually have this once it is done, that goes as a part of the ASPO requirement, that associated body which actually cover the safety requirements as an independent safety assessor in accordance to GEGN 8645. So so when you say the project is treated as CSM significant, the validation status is verified, accepted, and we move along with the project to go for the next. Anyway, if you have got any questions in the middle, you're most welcome to do so. So what we are doing, compliance and comprehensive signaling. So here we have the final project specification. Actually, I was having a talk with somebody in India yesterday, and they said we are following the process of FPS in India too now. So we have got a complete picture of what the project is, what is going to be working on, what are the different interfaces that is coming out with different signaling, what are the interfaces that is coming out at the different boundaries of the interlocking, and also what are the hazards, a brief idea about it, what are the stage works that need to be covered, and finally what are the standards that we need to follow to cover the project. So this is a part Indian Railway has working out, and of course all the other companies, the suppliers also doing the same. So we have got, so the second part is coming as a signaling scheme plan, the basics of all the requirement which actually covers the input of all the disciplines. So if we go on the disciplines, actually cover the telecom, the ENP, the civils, the systems, the PUA, and the OLE. All actually, because these things actually covered in the process of input in the signaling scheme plan, and it goes into what is called the independent review and independent assessment. So IDC and IDEA, and then when it is approved by all the departments, the scheme plan is approved for going on commissioning, which is actually forms a part of GRIP 4 approval. There might be some changes coming up according to requirements in GRIP 5 or GRIP 6, but that will again have to go for the process that we have envisaged in the previous cases. So the next part that comes as safety. So we have to safety we have defined previously. So we have got the hazard analysis, we have got the ergonomic, and so ergonomic is plays a very important view of those about the people that is going to work on. We have to think about the maintenance, we have to think about the suppliers, we have to think about the maintenance, the operators, and we have to think about the workload that people are working on. So we have to get the designs, we have to get the RAM analysis, we have to get the EMC analysis. EMC analysis actually covers that the product that is being installed at the site does not have an impact on it from any environmental aspects like any other what you call the EMC that means the overhead lines or the traction lines or any other frequency that is actually we are using a frequency track cycles and all others. Of course, we are using an IP protocols now, so security has come into a most important aspect in there. And finally, the environmental factors are also has a place in important that we are not destroying any trees, we are not destroying any habitats and all this stuff that's also taken into account. So these are all captured in the following standards, which I've already mentioned earlier. So it's the group standards, industry standards, and all the others. And then we produce a certificate of compliance, which is that this project is complied with all the following factors. I've just given an idea about a Thames link, and we have got the process about how you are going to do it. So what has been changed into the new and novel systems? The novel system has come with what I mentioned as the networks now. Network has played an important role into the new technology, which you call it as the digital signaling. The next one, the important of digital signaling is because people can access from outside, which is common as cyber security. People can access from inside, which comes as a physical security. Actually, just to say, I'm also working as a product security expert for ETCS on board. That's also a part of my job now. So I'm also looking at those areas. So security plays a very important role in those areas. And of course, the most important thing is interoperability. We are using an interoperable product that is used in Europe, and you trying to you do it in India, you do it in UK. Of course, it will be covered as part of India because some of the projects that they're coming up with ETCS has to cover this interoperable process that needs to go along with. So network compliances is very similar as that we do for conventional signaling. So they still follow the process. There is no defined process in the standards, but we are still following the process 11201. So people who are aware about it might get a good idea. Then we have got the typical network design, the Cisco routers and all the stuff that actually communicates to the to different components from line side to train board and all line side to interlocking and all the stuff. Then EMC compliance we have covered in the project file and in the EMC control plan. The EMC project file control plan actually covers the network components that are being used in the system might not have an impact on it from any external. That means the normal condition it should be at least I think 20 to 25 yards or 20 meters from any existing railway. So any product that is within the 20 meters existing railway must have to look at very details about the EMC compliance, but we need to provide an EMC project file to cover that it has got no impact on the product that we are trying to install at the locations or at the control center. Of course, again, we follow the same procedure as the certificate of compliance as we have done previously. Similarly, for security, we have got a compliance in accordance with ISO 27001. Anyway, I was also an auditor for ISO 27001 when I worked in practices, and I followed this process very rigidly when I was working for air command control systems of for NATO in Paris. So that was something which I had to do, and I had to cover a lot of military standards, what they call as MIL. For our part that we are trying to work out for security in our product like ETCS on board, or in the terms of the product that we are having the interlocking, that we're speaking about the Westlock and West is the communication that is taking place. Also, we need to ensure that we are covered by 6244324 and 21 in that aspects, and we need to go it rigidly on those areas to ensure that we have complied those. So follow, of course, the company business management system that needs to follow accordingly. So we need to cover like project security plan. So we have a plan how to do it. We have covered the threat and risk analysis and the validation of the system. Just to ensure that threat and risk analysis are actually captured as part of the security aspects, which is a completely different to the hazard analysis that you have actually covered for safety. So anything that has, suppose I just give some example like if you have got the penetration testing of a system from outsiders, handling of a physical handling of a system by breaking comes under the threat and risk analysis. But if anything that is coming as threat and analysis that has an impact on the safety of the system, that again is transferred onto the hazard, where you need to cover this as part of an open item for TRA and a closed item for hazard in those areas. So how will the interoperability compliance be achieved? So we have got the management compliance. So actually it says the network interoperability regulations that there is a clear and accessible technical standards that actually forms the railway interoperability regime. These regulations amend the railway interoperability regulations RIR 2011, which transposes EU directive 200857 EC, the interoperability of the European system, the interoperability directive. So we follow this process according to those requirements. So we have got the technical specification of interoperability. We have got the railway gov RTS compliance. So actually, I'll just give a bit idea, which is initially called the NNT, a National Notified Technical Rules. Now it is called the National Safety Rules and National Technical Rules. Like I just give you one simple example, like in a signaling plan, we need to ensure that there is no track circuit which has a length less than the length between the two axles of a coach. So that track circuit has to be defined larger than that. I think it is 20 meters, but the TSI doesn't say that. But signaling plan has to cover to comply the TSI requirement in terms of the CCS, that is 02081, which actually requires to comply all those. And those standards actually specified by railway RSSB, Railway Safety and Standard Boards, that these are the standards that need to follow. Again, how we do it, I'll come later. So those actually are the open points in the technical specifications of interoperability. So again, we have to go for the independent safety assessment. So these safety assessments comes on two aspects, which I mentioned earlier. One is the interoperable, which is NovoDevo, and the second is the ASBO, which comes as the system of systems overall. So now, before we go into our NS systems, we have to follow a lot of requirements. So in our systems, we have actually defined as 4 major requirements. We have to go for the system requirements, you have to go for the trackside subsystem, you have to go for the telecom subsystem, you have got the operational system. Let me just say one thing here. Initially, we're actually working on signaling. Now we are actually working on systems now. So signaling, which was actually defined as red, yellow, green light, is no longer a basic requirement. Now we have to cover a lot of inputs that comes up into the system requirement, which actually caters the final output to produce a red, yellow, green light. Of course, that comes with the normal conventional signaling, but it varies with that of the if we go for the digital signaling, which might not include the line side signaling, which is in level 2. It might include the line side signaling, which is in level 1, and also caters for the additional equipment that actually covers the aspect control for the train, which actually communicates between the EVC and the trackside systems. But in this case, we have to cover the 4 requirements, which are very mandatory, and we have got a different baseline for each of these requirements. And apart from that, we also have a client requirement to fulfill those areas. So if we go for the system requirement, we have got that conditions about unwanted braking, maximize the automated divisions, quality of service, type safe movement, and all those stuff. So impact on train drivers, risk mitigated by them, not adequately by ETCS, robust to understand intentional and unintentional threats, the working environment as degrade working allow instance problems. So these are the factors that actually covers the system requirements of the overall system. Now, this system requirements actually covers mostly as system of systems when you're actually coupling with multiple equipments for this work. So the next one is coming as the trackside subsystem requirements. So trackside says that we have got communications between RBC to RBC. We have got communication to the bellies to the EVC, that is on the train bone. Then we have got the conditions that we have got AWS, TPWS for the conventional signaling, and that has an impact on the bellies, and also that those are suppressed when you're working on ETCS. And at the same time that we if it is a bidirectional signaling, we have to cover for both directions. And if it is a permanent bellies, which is like what you call the this is actually they call it as the
fixed bellies. Fixed bellies.
Fixed bellies, yeah. So fixed bellies, which are actually they just provide the provision of where the train is, and that is there. But of course, ETCS 2 has fixed bellies and switchable. ETCS 2 has fixed bellies. ETCS level 1 has switchable bellies. So I will come a little details when I come to the bellies part later on. Then we have come as the telecom subsystem requirement. So we have got the communication that is takes place because we are using GSMR. We are using mostly uh, circuit switches. We are not using packet switches, but actually what happens is packet switches are higher broadbands, and actually what happens, this has a very much impact when you're when you're having a multiple trains, it cannot handle. So of course, it in India and also in other parts of the world where Siemens is also working, we are trying to work with LT, that long-term evolution, which actually covers for 4G. So that is a new evolution that is coming up as part of the new requirement for communication for GSM. Actually, GSM I think will die out of something by 2030 or something like that. So that's something we need to cover. Then we have got the operational requirement. The operational requirement cards about how does the operation, how does the that is start of mission, end of mission, communication. And then we have got the entry into the sidings, exit into the sidings, then the movement authorities and all. Those are the things that is taken place as part of the requirement. And one of the important thing is key management of the ETCS, which forms a part of the security aspect. How is the key managed? There are two things in the key management scenario. The one is that key for the use of ETCS, that is the RBC, and this things comes as the EVC key management for the EVC on board. So there are important factors. This key management is a part of the requirement that we provide as two aspects. One is the physical key, and the second is the cyber key. That means a communication that is taking place between the person who is trying to operate and the person who is operate and is not allowed to operate. So that's something is a very security part that we also covers as part of a security aspects. So what are the requirement management exam? I was given some idea, the trackside equipment or the train control equipment, because there's something which you have covered, and we say that traffic simulator, the lab systems, and we have agreed on all this stuff. So there's a thing that we have taken it as a part of the examples, and also given some of the examples of subsystem requirement specifications snapshot. So what is TSI? So actually, using railway standards, so TSI has been replaced by NTSN. NTSN actually covers, because after the Brexit, where RSSB has taken up the complete TSI process and have produced their own requirements in terms of the NTSN, but actually they have changed the name, but they haven't changed the contents. So we are still using the same content that we are actually we have captured for ERA, and now it is called as National Technical Specification Notice. So actually it covers the 7 chapters, which covers the subsystem definition, essential requirement, characteristics of subsystem, interpretive constraints, conformity and suitability of its implementation, and there are a lot of annexes. So this is actually covers a different about a few subsets. I shouldn't say few hundred, but quite a large number of subsets, but all the subsets are not applicable for all. So I'll give you some ideas about how the subsets are and how we are going to do it. So when you're coming into the picture of TSI, there are a lot of inputs. So this is something I'm trying to divert away from the concept of the basic safety requirements to the next level of national, the interoperability requirements. So the interoperability requirements, so what actually we have got ETCS trackside, we have got ETCS onboard, we have got the ETCS telecom. I'm still using the GSMR, which might be replaced by LT in the future. So ETCS trackside, we have got the TSI subsets, we have got the NTR that I mentioned earlier. So those are the two things that cover for the ETCS trackside. Then we have got the ETCS telecom, we have got the again TSI subset, which is subset 93, and then it is not mandated that we need to comply, but it is expected that you need to comply. Then you have got the MORIN, which is covered by functional requirement specification and system requirement specification, which is the current version is 8 and 16. So it's the mobile radio for railway network in Europe. And we have got the IRIN, European Radio Network for enhanced network. So this actually covers, these are the 5 vital parts that we need to cover as part of the TSI compliance requirement. And this is, as a result, this becomes a very complicated process. So ETCS onboard covers from the trackside and from the telecom. So it is common for both of them, and this covers all the 5 areas. So why is compliance required? So according to European Commission, we need to ensure that all our systems and subsystems are followed by the regulations, that is 919. And the one that we are actually trying to use is the set of specification defined as 360, because we have actually used that 230D initially. Now this has updated to a new version as 360 for the that is subsystem, that is a system requirement, that is FFSS, I think. So that is a form fits system requirement. So that actually comes as a basic requirement, which comes under subset that is 26 for the whole of the product, for whole of the ETC systems, and then followed by multiple subsets going forward. So we have got a number of subsets. So what important factor that we actually identify is system requirement specification. So that is what is the most important baseline of our ETCS requirements. There are a lot of others, but we do not require to follow all of them for a project. There are certain ones we require to follow, but there are certain ones which are absolutely mandatory, like subset 36, subset 40. Then we have got, excuse me, subset 97 is coming up slowly. Then you have got the testing subset 85. So subset 85 again is a part which actually covers mostly from the manufacturing point of view. They do cover all the testing requirements in terms of the statics and dynamic test at the site for all the products that they are issuing, which actually provides them ISA for the products. Anyway, I'll again come back slowly. So So what is NTSN? It is a structural adapted in 2020 with a description of the conformity assessments of interpretive constraints of the EC verification. So the most important thing that is coming out is that this is the one that actually applied for the work that you are doing to do with the Railway Safety and Standards Board. So how does this work? So when you have the conformity assessment of interpretation, you have got all these conformities. That means CA, CA1, CA2, CH, CB, CC, CT, CF. So it is not mandatory to cover, but there are certain things which has to be covered as part of this manufacturing point of view. But the two most important things that needs to cover are the CB and CD. CB and CD actually covers how the products will function when it is in the when it is placed in the infrastructure, how the product will behave when it is coming with adjacent any other impact. So these are all being tested. So in Siemens, we have a 5 gigahertz testing for the lab. For EMC, we have got some other testing, some vibration testings, and all those stuffs that is covered in Germany. And we have got the quality management system that actually covers about the production of the system, that they follow the process, and of course it has to be complied with ISO 9001 requirement, and of course some other environment like 14001 and 18001 about both environment and health and safety. So once we get the CB and CD, that means they get a certification. That certification is valid for 3 years. So every time you are trying to use a product into our system, we need to ensure that product is certified for this use. Suppose a product is certified in 2003 and we cannot use the product in 2007. We have to go for a second certification to use the product in 2007, and all the products that are being used in 2003 has to be certified to go into the next part of 2007 for if we go exit 3 years. So that is another big factor for any manufacturer to go along with. So the third one is the EC design certificates. Again, that is a part of which forms under the EC examination. So that also forms CB, and CH1 forms under the CD process. So what are the things that we need to cover for the manufacturer point of view? Manufacturer actually goes for design, manufacture, then they are carried out conformity assessment. At the same time, they do the C and CC, sir. So if we look at the, if I just want to share one thing before that. So C is the internal production and C is the conformity based on the internal production control. So that is the part that actually they are doing as part of their requirement in terms of the manufacturing point of view. But when it comes out in terms of the notified body, they actually covers the issue. So they cover CB and CD, and they produce a certificate for independent safety assessment and the European Community certificate, which actually mandates that this product can be used for any outside UK, outside the European and any other places. But we have to follow a different procedure to follow to adapt it when you are going in a different country. So when you are coming as part of the final assessment in terms of the product that has been used, so we need to ensure the first thing that we need to is ensure. So we have got the EC type examination, which is a part of the CD, and we need to ensure that the CD that we have actually captured in CD has also been captured as part of the product requirement when you're trying to use the product with other system like a Belize, like an RBC. So we ensure that those environments are still captured into the areas when you're putting into the system. And as a result, we need those certificates are still valid. If there is a variation, we have to cover separately. One of the important thing that came up into my Belize that Belize requires identification of on either side of the Belize of either ends. Actually, the Siemens has produced only one end, so that was a non-compliance, and it was very difficult. So I had to provide a risk assessment and provide a justification to ensure that the identification does not have any impact if it is not provided in terms of the safety when it is placed on the track. Then we have covered the EC verification of the product. So this is actually coming up as a part of the requirement which when are trying to do the application of the product into the infrastructure. So these are two factors that is coming. So we are coming into the interoperability scenarios, and these are the things that we need to cover in depth in those areas. So how does it cover? So when you're trying to do an examination of SB, so actually it covers the technical design is suitable to be used for the product to be used, covers with the TSI compliance in those areas. That's why because it's one of the reasons why I had visited Germany, Switzerland, and Madrid, and many a time to work out that this product is suitable, because I've actually covered for Germany, I've covered for the switchable and the non-switchable bills. Then I have for Switzerland, I've covered for the line side equipment unit, and for Madrid, I've covered the RBC. So I have covered that. They have covered the CB and CD. I have to cover all those areas supported by the safety case, because these are important to get a product approval or the initial product approval for going into the trial for using it on UK Railway. Next is that means system fulfills all the requirements, the designated subsystem. So as we provide them, it is covered. When you're putting in the system into the overall system architecture, it actually covers all the requirements. If there is a derogation or again non-compliance, again the configuration of the equipment with any other product, that also has to be taken care of, and any issues identified has to be captured in the change control board and has to be rectified accordingly with the certain changes either in the software or in the hardware accordingly. Then when you're trying to use it for the SF, the important thing is this SB actually forms a part of gas, that means generic application safety case. That's a product is generic to be used in areas, but there are certain conditions that need to be adopted when you're trying to cover for specific application safety case, and you have to cover for those areas. So the first important thing is ISA reports to complying of the common safety methods, which you have actually the basic safety requirement that needs to cover, that it has covered all the safety requirements when it is being used as a system of system. Then we have got the subsystem. That means that we have the system that when you have actually covering into the areas, we have covered all the hazard analysis. We have drawn the subsystems. Any derogations comply, any derogation that has been covered in terms of the system requirements onto the subsystem, overall system of system requirements is also complied. Before it, we can issue a final safety case of that. So there are two things that is coming up. One is the ASBO, the other two things are the NOVO and DBO, which I mentioned earlier. So as a part of the requirement for the NOVO certification, we have to cover SB, we have to cover SF in terms of the clauses that are defined in all the subsets that is covered under the CCS-TSI. So TSI subset, I'm just giving an example what actually we have actually covered. So when you're actually going for a NOVO, we have got so many subsets that need to cover that we have actually worked for. Subset 26, 35, 36, 39, 40. So if I just draw one of the areas, so if you see that we have got the several inputs that need to go for each of the subsets, like application designs, location. So I had produced all the processes according to subset requirement. And if you go in, if I just run through the areas, so these are all the things that we have actually captured as part of the compliance. So these are compliance which actually relates to the respective subsets and can cover. So you can understand that is environment for the Belize. They have got the IS safety application rules. We have got the SAS. We have got the installation report. I have all those. The two subsets that I missed the CSI. The two subsets that I didn't cover are this 98 and 39. Actually, those are captured as part of RBC handover. So those are the two things that will be coming up as part of the new requirement when you're trying to do for the new for any new projects, which is based on the 360 and of course for any multiple RBCs that are being installed on the circuits on the infrastructure. So these are all the individual components that we need to follow in terms. I've just given a brief outline of course a bird's eye view. Then we have got the NTR. So we have got, I just give some definitions, the national safety rules, which covers the European Union. Then we have got the national technical rules, which covers the TSI, where TSI is not sufficient. Then we have covered the GB railways, actually, the which I mentioned earlier, the railway group standards actually covers the GB requirement. And then we have covered the what does it contains, that it ensures that when a vehicle is placed into service, it must cover the subsystems requirement, it covers the vehicles requirement, it covers that, of course, it covers all the others associated with the operations, associated with the drivers, and all the stuffs. Then we have covered the notifications, and finally we have actually covered where we get this. So RTS can be found. So this actually is covered as part of the issues which actually comes up every 3 months for RSSB. The most important factor and the difference that lie with the conventional signaling is when we freeze a project at GRIFO level, we'll continue the same baseline throughout the project if there is no mandatory requirements coming up as a letter of changes that comes into the project. But in this case, we have to cover the latest baseline that has been covered for the NTRs, and it has kept us a very important aspect about compliance, because if a standard change about a week before commissioning, we cannot do a mandate to complete those requirements if it is coming up as a new standard, new equipment. So those are things we have to cover with operation of railway authority and road regulations rather, and ensure that we have captured up to a certain level before we can ensure that we have captured all the things and it is safe to do so. So we have mentioned about the designated body, so it addresses open points. So I mentioned about the TSI. There are certain things in the TSI which actually doesn't cover in the TSI, but we have to cover as actually these open points are actually covered as in the next part of that is the 2281, the subsets that actually covers. Then we have to cover to inform the member states, and we need to cover the European community. So what actually we have covered. So when we did a project in the past, we have covered this about 9 requirements. Like this is the things that actually mandated by Network Rail. So we have covered all these requirements into compliances. The most important thing that I like to stress here is that these compliances are not similar to the compliances that you have covered for conventional signaling. In the when you are doing an engineering certificate of compliance, the ECC, we mentioned that this design is compliant to say sub 110 module so and so. This is compliant with those the respective number of them of the group standards, company standards, and also in this case we have to comply each of the clauses separately, and that is a big work to get these clauses done. It is a massive work. I'll come to show you how massive it is. So each of these clauses has to be checked up, identify the requirements, identify the non-requirements, identify the justification of the requirements, and then provide evidence of the requirement. So that is quite a big task. So what is an independent safety assessment? So I've covered the 3 areas. So one is the applied body. So they look at the safety, reliability and availability, health, environmental, technical conformity. The DBO covers the one that is open up as part of the open points of the TSI, and it is again covered on the railway regulation 21.1, and of course current open Nubo can perform for apply also for a DBO. So what actually happens is that it has changed now. A single Nubo can also act as a DBO, but it has to be an independency between them. The second is okay. The third is the assessment body. So we have got the system definition, which is a part of the requirement for the safety as part of the CSM requirement. Then you have to find out the hazard identification if it is significant or non-significant. Then you have got the risk evaluation, demonstration of compliance. You have got the safety assessment report. So that forms a separate part of the assessment from the safety point of view. Important thing, the ASBO, it forms a part of the input for the NOBO, which actually comes under subset 91 and also under group standards 8026. Then actually a single organization can do all the ASBO DBO, but it has to be independent about, and there should be and conflict of interest should be taken into consideration. So if we do all this process, so what actually we have achieved? So if a typical compliance, what you're doing for an Eurobill is, so if you see, we have got the two modules I mentioned. One is for the generic application safety case, and is for the specific, that means application specific application safety case. So if we look at the areas, so we have got a certain conditions of those, like we have got the IC cert, CB, CD, we have got the technical dossiers, we have got the EMC. So these are all the part of a static test that actually covers. Subset 85 actually covers all the tests that has been taken place as part of the manufacturer. We do not require to comply subset 85 as part of the compliance of the when you're doing the installation or doing the commissioning of a product, because that is part as coming as a separate test and commissioning plan, which covers a separate unit, which covers a part of subset 85, but not mandatory that you need to cover here. But it is mandatory they need to cover subset 85, and it is a requirement for getting a product approval of the product if you are trying to use it in the market for UK. So if you are going for the module SF, we have got actually the citing forms I have produced as part of the subset requirements 36, and you have provided a separate. So we have EDGPG is a data generation plan. It is a data generation plan. I'm just giving some of the ideas. So it defines where the bellies are placed, which actually covers as forms of the application safety rules. Then you have got the different processes that need to follow, and need to ensure that those processes has been captured and ensure that the bellies are suitable to be used in the infrastructure after commissioning. So this SF is covered under covered under subset 36. There are some actually are covered under subset 40. There are partly some aspects are covered as part of subset 26, but there are also like other subsets also that also needs to be taken into account. Now the most important part about the safety compliance. So as we have mentioned earlier, that any safety compliance has to cover through hazard, safety case, and hazard. So we have put the hazard log, we have to identify the hazards, mitigate the hazards, close the hazards, we have produced the hazard, then you have to go to the safety case. So what we do for conventional product, we get, this is actually forms a part of common safety methods compliance. And the rest of it is the process that we follow. We go to the same system review panel, the network rail acceptance panel. They're happy that you have covered all the processes. They have identified all these requirements. They have also nowadays they also look at the requirement that is defined in the contract technical work scope, and the CRD or the CM produce the certificate of compliance. Then they get the CIP approval, and it goes into service, entry into service. So that's a process that we have followed. But when you are coming at the approval process for the interpret product, it is a completely different ballgame. So when you're coming for the interpret product, actually, I have mentioned earlier that we have to comply two conditions as SB and SF. So when you provide an SB, so we're actually providing the gas that has been produced by the manufacturer, the CBCD cert, the ISS cert, the product cert. So that actually covers from mostly manufacturing point of view. So we need to ensure that they have captured all those areas before it is coming as part of our application. So actually, these were not done in the process that we usually follow, and I had to work out on this process and made the people in all the three countries work out accordingly what actually I was looking for. So then we have to go that we have put the hazards, the application safety case, we have put the hazards. Now we have got, again, it covers the system definition and comes as a project authorization strategy, how we are going to implement in terms of project. That is a part of the new digital railway requirement that we have actually coming up as a part if we are going to commission a product in a digital signalling. So the next part is very important. So initially, what you get a safety case, we actually get initial approval. Oh, that's fine. We are doing these things. That means the project authorization strategy has been accepted. The system definition has accepted. The hazards has been identified and is given an initial safety approval. But then that actually complies the CSM and the ASBO. That's the first part of the work of the product. Then when you're going into the systems, we have got the subset 91, which is a safety compliance, which I mentioned earlier. That actually covers from CSM part. Then we have got the technical file, which includes all the inputs from other subsets. So everything that is covered from other subsets that I have mentioned earlier goes all into the technical file. So this technical file is being reviewed by operation of rail and road before they allow us to go for authorization for putting into service. So they must be happy with that. We have covered all the input, we have covered all the evidences, we have justified the evidences, and we provide compliance to all the evidences. Then we have got the final system review approval, because once they are happy, water is happy, then you can go for it. So there's a big iteration process that takes place when you're producing technical file, when you're producing the compliances. Then we have got the, when SAP is happy, then if our independent authority, they produce the certification. Okay, we can go it. This is again a temporary certification which actually covers a part of the initial what we call the DRACAS process, the data recording analysis and cumulative action. That means one of the things. And later in the final, when it is commission, is coming as the FRACAS final failure recording analysis, and it goes for at least 2 years for all these new products to ensure that the performance and the reliability of the product is still achieved what you are trying to go for after commissioning, and there is no safety impact on the product. Then we have got the certificate of compliance. We have got the again this competent independent person approval, and we are getting for the entry into service. So these are the process that actually follows, which is a very complicated and very tough process that we need to follow. The next comes is, I was speaking about the compliance. So when I did for Thameslink a project, I had to comply around 9,791 clauses to cover all the insurance that you have to cover. So you've covered all the certain this, and there are certain things which are covered by ICSAT, but certain things which has been covered as part of SB and SF. So that is it is a very tough subject, and I have defined the process of how to do it now. So it is a very clear and straightforward process, but it is not, it is still laborious, and that is a big challenge for us in the future, how we are going to comply with all those areas and can work out about the process that we need to follow. So of course I haven't added the NNTS. That's an, I guess, segment part about depending upon what are the standards you need to follow in those areas. So finally, where you will get this, we have got the directives where you get the European Commission. I've got this links. I've got the ETCS website, and you have got the RSSB and all this. I think that ends for my presentation. I can't hear you. I think you're in mute, Mr. Banerjee.
Yes, sorry. Thank you, Mr. Roy, for a excellent presentation on very complex subject. Very difficult if you look at it, given the steps and the number of specifications to which compliance has to be achieved. So, but before we say anything more, I would like to check if you have any questions from among the guests attending this meeting. Do any of you have a question, Roy, to respond to? Okay, well,
I think people are not very happy.
that is, it is quite a heavy subject, and
It's a very heavy, it's a very complex subject, no doubt about it.
Yes, just to make you.
Banerjee,
Yes.
I think that this compliances requirements will be varying from country to country. Of course, the basic compliances with respect to SANLEC standards would remain the same, but like in India, like for metro certification, we have to take RDSO's clearance, and they require certain different set of all sets of documents. So I think there may be some variation. So naturally, this is something some sort of a regulatory subject. It's not really something which where there can be questions: why this document, why not that document, like that.
One thing is it do vary from country to country, there's no doubt about it, but there are certain aspects of these standards that need to be mandated and complied before it is going into service. So you might not follow the full requirement. There are certain countries that are trying to say that we are cannot follow the European community to a great extent, but there are certain conditions that we need to ensure that a product, when you're trying to install a product or you're trying to install a system into the infrastructure, we need to ensure those are captured in depth. So what I have actually captured in here is mostly associated with the European train control systems, not a part of the CBTC requirement, because when you're coming at the mass transit, it's a completely different scenario. So, but there are certain things like ATP, ATO still covers there, but when you're coming into CBTC, we have got the ATS and all the stuff. So that's something which comes on separate requirement, and that will be covered mostly from RTSO requirement, and also covers from some of the conditions from like your other conditions that is coming.
As I mentioned, that self certification requirements generally most of the countries, other than probably US and North America, everybody for most of the countries follow the CENELEC standards, which are basically Central European standards. Or now US railroads also probably are going into the CBTC system. They are also adopting CENELEC standards gradually. So I think ultimately most of the countries would, but as regards as interoperability is concerned, CBTC still is there's no question of there's no interoperable standards for CBTC as of date today.
Yeah, I agree with you. But when you're speaking about CENELEC standards, it actually forms a part of the requirement of the safety procedures, the safety approvals. So all the CENELEC standards comes under safety requirements. So the things for interpret doesn't include any CENELEC standard. It includes a complete different set of requirements, which actually covers from the ERA-TSI.
I have a question, sir. In this whole process, we generally come across the body, the independent safety assessor. Now, in your presentation, that exact reference to the independent safety assessor, I didn't pick up. Is that something which is like continuous overall in the system, or how does the independent safety assessor fit into this whole scheme, so to say?
Yeah, so the first part, when you're looking for the safety point of view of the product, it comes under the independent safety assessor for safety only, that is as per requirement, which actually forms a compliance of the different CENELEC, the EMC and environment and all those stuff, including the security. Now, when it comes as the part of the overall system of systems, when it's come as a part of the interoperable product, it actually, the independent safety assessor doesn't look into the areas of independent product now. They're looking as the overall system of systems. So when you're looking at the overall systems, if you look at the system architecture, they are not going to see about what is an RBC doing, what is a point doing, what is an interlocking doing, what is a control center doing. They ensure that the product, that is the whole system of system, adheres to the requirement that when a communication is taking place between the track side and the train and the communicated to the RBC into the interlocking and back again from the control center are all being captured in terms of the clauses that has been defined in the TSI. They look at all these requirements and they need evidences that those are being taken into account, and evidences come as part of the test cases, test report that has been produced by the testers. So that actually covers the independent safety requirement for the interoperable product. The other thing, like that is for coming as a NOBO or the APO. The other part, when they're doing as a deeper part for the interoperability, they look at the compliance of the ECC European certificate of the engineering certificate of compliance. They look at all those areas that they're compliant with those requirements, as I mentioned about the track circuit, as I mean certain things like, suppose when a train is approaching or moving into a station where it is a conventional signal is there, he might not take into requirement of the signal. The signal might be rate for some reason or the other, but if he has the movement authority to go for it, the signal is dead because you have to stand at the station. But if he has the movement authority, the train can still go and pass the station. But of course, that we have actually captured the train will not pass if it is red or means black. So those are the things that they need to look into as part of the standard compliances in terms of the DBO, and they cover a separate part for compliance of the area. So independent safety assessor covers NOBO, DBO separate, ASBO separate, and this NOBO, DBO actually they do it as the overall system of systems. ASBO defines as a system and also a part of the overall system that goes into the NOBO DBO. That's why I mentioned earlier that when you're doing a system, the safety approval of the final product, that is the ASBO, that actually fit into requirement of subset 91, which actually covers for the NOBO DBO part. So that's why the independent assessment look in those aspects. And I've covered that separate. Yeah.
So kind of the ISA basically is like the big daddy looking over the whole thing.
Yeah, they look over the whole system of systems part, basically. Yeah.
It's beyond, I would say, the scope of this particular whatever you have described here. It is sitting outside and there or whatever you are covering.
Yeah. So Yeah. So IS actually looks the SB part and the SF part when they're doing for the ABBO part. So they look at both the areas and they make comments if they find that is something is missing or something is not provided and all those stuff. So they cover all those areas because they don't look at individual product at that time. ASBO covers the individual product and the safety of the product when it is used with other applications.
And then just another question again, maybe repeating. It's we what happens or how what exactly the defects management is covered in the sense that you have a requirement and then down the process some defects are picked up in the system which shows the non-compliance. So how is that the management of a defect, is that mandated in any of the specifications specifically, or it's just like we do for normal cases, a defect comes, is reported, and then somebody fixes and it is retested, you can say?
No, actually, when we are trying, because in the new systems, what we have the railway, the what you call the rigs, that the railway simulation server RSS. So they actually covered all the scenarios when a train is allowed to move, and they are doing actually something like a complete simulation of the system. So they try to identify if there is a failure in a system, if there's how this is captured, how we are still continuing with the movement authority, and also how we are trying to cover the train movement so that there is a less loss in time. So those are all being captured, and this capture comes in under the change control board and is discussed during the change control board, and actually what we call as a soak test, and in UK we call it as a DRACUS, that is data recording analysis and cumulative action system. So we identify all those areas, look into those areas, and we test those areas that this system is captured. But one important thing I like to mention, if we're traveling on ETCS level 2, it is a very difficult scenario to come to ETCS level 1 or level NTC in those areas, because it is very difficult for the interlocking to couple those requirements into the data preparation to cover those. So we are because the failure that actually communicates and happens during ETCS level 2 is the failure of communication between RBC and the EVC of the train, but that is still taken as quite a it's taken as quite significant that it will not have a failure, but still we take into consideration that we are still having the interlocking and we need to complete about the as per the procedures of a train movement if there is certain taking place. Like when I was the independent beat reviewer for NCRTC in India, there was another case that what actually happens in during the disasters management if there is a train lost into the area between the two block sections, because they have signals, they have two block sections, but if the train, because they have pseudo block sections which they define as ETCS level hybrid. So when a train is lost in, they are trying to have mandated people at each of the stations so they can then use their normal paper line clear to cover from one station to another, and of course there'll be huge loss of train timings and all this. So those actually has to be taken up as part of the simulation process and is captured in our as part of the simulation process, and it before it finally goes into testings and the data is updated accordingly to ensure that those are captured. So in terms of the safety, we are actually highest in there might be some errors that is coming up, like if a train passes a Belize and doesn't give as communicate with the Belize and the train. If we have the similar situation between two successive Belize, we take a scenario and we get into the GRU, there's a juridical recording unit, and we get the information from there and we communicate to that and we do the according testing why there is a communication gap. But if the single Belize has missed out, it will not provide it and doesn't have an effect on the safety of the system when it is passing over.
Thank you. Yeah, any question anymore? Yeah, please go ahead.
Sorry for but missing of single bellies alone would be recorded in the GRU, I suppose.
Yes. It might no, it might be, might not be. We are still fighting with that, but it is actually most because single Belize doesn't have an impact on the train movement, because we do have two Belize's on either side. That is, one is the direction and the second is the position control for the passive Belize's, and for the and for the switchable Belize's we have, of course, if we miss a switchable Belize's, we are actually losing the aspect of the control of that signals before you can move. That is ETCS level 1. So it is more applicable for ETCS level 2, but not more for ETCS level 1. Oh.
Thank you.
Okay.
So, if there are no more questions, I will thank Mr. Roy once more for the excellent presentation and I would say making a very difficult subject simple enough for this audience like us. Thank you very much. Roy?
Thank you very much. Thanks for having the patience to listen to me for for an hour.
That was all interesting, I believe. And as I mentioned, this will be added to the public viewing shortly. Take about a week to make it ready. Thank you all and joining this presentation in this evening and the morning and afternoon. Along the job. Thank you all.